So hello everyone, I'm Sam, and today we're going to be talking about how you can run a software company without needing to hire an operations team or an SRE team. We'll be discussing how operations has changed over time and how that affects developers. And this whole talk is going to be coming from a developer's perspective. If you're not a developer, so if you're a manager or if you actually run an organization, then actually thinking about how you might attract the best developers possible and how choosing whether you go with a NoOps route will actually make it easier for you to hire the best talent. I'm Sam, and I've been working 100% serverlessly with AWS for the last 4 years. For the last year and a half of that, I've been running a consultancy working with small startups to small businesses around the world who are using serverless and helping them make the most of that so that they can get the competitive advantage. I've also got a YouTube channel where I teach developers to use serverless to actually build some really impressive and powerful solutions. So to start off with, we're going to look at the history of operations and how developers were involved in that. So at the very start, we talk about how there was on-premise technology where you had all of your servers in your server room. The developers often would not actually have to go to the server room because you'd have a whole dedicated operations team managing and controlling the servers. Everyone likes to think that their servers and their server room looks like this beautiful picture here, but in reality, it often ends up looking a lot like this. Things break down, equipment needs switching and replacing, and over time you end up with this massive spaghetti junction of wires, and it becomes really unmanageable. This is where you'd have a dedicated SRE team or a DevOps team who are managing all of this, and from the most part, your developers won't have to touch this, but obviously having a whole dedicated operations team can become costly. To avoid all of this physical management of infrastructure, a lot of companies moved towards managed data centers. This is where you pass your server setup to a company and they install it, monitor it, and make sure that it is running as optimally as possible. Some of the big advantages for you as a company are the fact that you're no longer responsible for maintaining the running state of that machine, as well as the physical security and digital security of the facility. And finally, the internet connection to these managed data centers is often far superior to the data connection you'd be getting to your standard office. So whilst this is really good, there are still some negatives. You still have a fixed number of servers. So as a developer, you need to be thinking about not only writing good code, but how many users or how many transactions is this process going to use, and therefore how much compute units or how many servers do we need to have. From the operations side of things, you're still responsible for upgrades and any failures of parts on your servers. And finally, you're still running bare metal. This means you've still got to manage the BIOS as well as operating systems and any other patches like that, which adds to the operational overhead. And whether that sits with an ops team or with the developers, it's extra cost for yourselves. So the next stage was cloud servers. So this is something along the lines of EC2, Google VMs, or Azure VMs. These have the advantage of being pretty much on demand. So this means that whenever you need a more powerful compute unit or there is a higher demand from your users, you can get extra servers to meet that demand. I'm going to lump in Kubernetes and all of the clustering solutions into this group. As I said, this is going to be a simplified history. This has reduced your operations costs because now you don't have to as accurately predict your future demand, because whether it is in a day or in a month, you can always get a new server. And if you decide that there are high levels of traffic in the middle of the day and low levels at night, you can scale up and scale down your number of servers to match the traffic. This does leave over quite a few operations tasks, from monitoring and provisioning the capacity. Even if you've got something like auto-scaling groups, then you need to manage the auto-scaling policies. And whether this sits again with the developers or with your operations team is often up for debate. This means that there's optional extra work that developers will be taking on beyond just writing the code. Developers also need to think about redundancy and failover. What happens if the server that's running your database crashes? Where is the data? Is it backed up? Is it redundant? And this can be a very complicated thing to have multiple servers and have it all performing as optimally as possible. And lastly, it's the networking. So is there a VPC? Are there subnets, NAT gateways? Getting all of this set up so that you are both able to provision and serve your application, but also secure so that you don't open up vulnerabilities where you are open for attack. This is all extra tasks that need to be completed. The next big step was moving to serverless. This is a massive change because now we're talking in on demand in the truest sense of things. So with Lambda, if there are more requests, AWS automatically spin up new instances of your machine or of your Lambda instance so that it can handle that throughput. It's also simplified in terms of networking. Your Lambdas and your Dynamo tables are completely isolated from the outside world unless you explicitly add access patterns, such as API gateway or the newer Lambda URLs, so that you are much more secure inside where is running your code. And if someone wanted to access the actual code, it would be very, very difficult. Also, with serverless, you have some really nice advantages. With DynamoDB, there is built-in availability zone redundancy. This means that if one of the data centers in your region you're running your Dynamo tables crashes, then all of the data is still available and is still accessible through the other availability zones. This means that as a developer or as an operations engineer, you don't need to consider or think about how you're going to do availability zone redundancy, which massively simplifies the workload that you have to do. Now, serverless is great and has completely changed how developers can build solutions without needing to master operations, but there are a couple of new challenges that come along, and these are often the things that people raise whenever they are opposing a serverless implementation. And that is that although Lambdas scale horizontally, you still need to give them a size for each Lambda. Knowing exactly what is the optimum size for a Lambda, as we've talked about in the previous talk from Nikhil, that is often very difficult. There are different ways of doing it, but getting it right can be hard. The second part is cold starts. Again, Nikhil talked about this earlier, and this is where a Lambda starts up, and there is a short initialization time for each instance the first time it is called, and we need to find a way to resolve this. So on the next slide, we can actually make the use of the Sedai platform, which can autonomously optimize your Lambda functions in terms of its memory. So in this example on screen, we can see that before we have a duration of over 3.9 seconds, and we've reduced that to 0.2 seconds, a 94% decrease in the average duration, whilst also reducing the total resources used. This has all been done by autonomously monitoring your Lambdas and then suggesting a new memory capacity, In this case, moving it from 1.54 to 2.3 gigabytes, increasing the memory by 50%, but actually decreasing the total resources used. Since this example optimization has been implemented, we can see that there has been an overall savings of 1 day and 11 hours of Lambda runtime, which is a massive saving, and also your users are having a better experience. Now, to optimize these Lambdas, you need to tell Sedai whether you want to optimize for speed and performance, or whether you want to optimize for cost. This can be auto-executed, so Sedai will implement this as soon as it has a recommendation, or you can have it recommended to you and you manually apply that. At the bottom, we can see there is a priority. So if you're prioritizing the decrease in duration, this might be a Lambda where the user experience is really critical that it is fast. So a shopping checkout cart is a good example. But you obviously don't want to make it infinitely fast because that would make it infinitely expensive. So you can say, make it as quick as possible, but don't increase the total cost by more than 25%. If you were going with a batch process, such as image resizing, then you could say, actually, we just want to focus on making this as affordable as possible. So decrease the cost, and you can then say, but don't increase the time it takes by more than, say, 40%. Now that you know how to optimize your Lambdas in the Sedai platform, we can look at how Sedai also helps with the other issue, which is cold starts. As you can see on screen, we have an example where multiple requests are made to a Lambda, and each of these horizontal rows is an instance of your Lambda. When the first request is made, it has to install that instance of a Lambda, which involves downloading the code and setting up the runtime. This cold start depends on how big your code repo is, as well as your runtime and a couple of other things. If you have a second request whilst the first instance is busy, then that will have to also initialize, and it also has a cold start. With Sedai, we're able to automatically trigger that Lambda function so that it initializes and that cold start happens, but that happens before you get any requests. This means that when the first request comes in, the Lambda instance is already initialized and therefore can run and return as quickly as possible without that added delay from your cold start. This is really important in response time critical applications, and is a really nice feature that you just don't need to think about when you're using the Sedai platform. The last thing is provisioned capacity. This is a feature inside Lambda where you can say, I want there to be 5 instances of this Lambda always available and always initialized. This means when you get a request or you get 5 requests, then the Lambdas are already primed and ready so that they can instantly process it without any cold start. Another advantage of having provisioned capacity is that you know there will always be at least 5 of these Lambda instances available in case you're getting close to your total account level Lambda provisioning. This provisioned capacity is something that is often very difficult to work out, but through Sedai, it is able to work out what it believes is the optimum value for your provisioned capacity and implement that for you on all of your Lambdas autonomously. So, what are the real business impacts of all of this processing? So, the big question comes down to, for your business, who does your operations tasks? The main 2 options are your developers or an operations team. As I said, this talk is trying to aim at the developer's perspective. So as a normal developer, there was some research and they found that on average, you only spend 4 hours per day actually working on the code. The rest is on business tasks like PRs and all of the rest of that kind of everyday tasks. If you are adding an extra hour of operations tasks, you're now decreasing your developer efficiency by 25%, which is a massive decrease. If you say, no, we want to keep our developers as efficient as possible, you could say, let's hire an operations team. In this case, you'll very quickly find that a DevOps engineer can cost on average $105,000. This is a lot of money. It's the equivalent of a 10 gigabyte Lambda, which is currently the biggest Lambda, running 24/7 for almost 20 years. That's actually longer than the total time that AWS has existed. So yeah, that isn't an ideal use of money. The third option is if you're using serverless, no one does operations. You pick a sensible default size for all of your Lambdas. You don't have provision capacity, and you just accept that you're going to have cold starts. Well, you can do that. And I've worked with startups that have said, we're small enough that that level of optimization isn't ready and we need to build fast. But in those cases, you're wasting performance because you've got cold starts. And also, it could be that one Lambda, you could increase the memory by 50%. And as we saw earlier, get a 90% reduction in both the duration and the total resources used. Or you could have Lambdas where most of the time they're sitting waiting for a second request made to a third party, and therefore being a lower memory API endpoint would actually not increase the duration, but would save you up to 16 times the amount of money. Finally, one extra little bonus is that the Sedai platform has release intelligence. This is where it monitors your Lambdas before and after a deployment, and it is able to tell you quantitatively whether there is a improvement or a decrease in performance from your system. This could be as simple as one of your Lambdas is running slower, and that is something that is really nice to have as an extra added bonus. So in review, as software hosting has moved from on-prem to cloud and serverless, operations tasks have reduced and simplified, and often that has meant moving it onto the developer. Lambda sizing and cold starts are the main operations tasks still left when using serverless, and using Sedai can autonomously help solve these problems without adding extra workload to your developers. So thank you, and I believe we have a couple of questions. So question 1, how much of a time saving can developers get if they use autonomous and serverless? So from a development perspective, I found that developing with serverless compared to even an EC2 based development process, we've been able to deliver features in around 10% or 20% of the time it takes to deploy an equivalent app using EC2. That's because a lot of functionality is relatively pre-built for you in AWS. And that means that you can focus on writing the code and developing the features instead of thinking about EC2 sizing or networking or any of the other more nuanced things that are usually outside of the focus of a specialized developer. Are public cloud providers expanding their serverless offering? How does this impact developers? So yes, they are. Serverless has been growing at a rapid rate. And because there are more and more companies and more enterprise customers using serverless in production, it means that all of the cloud providers from AWS to Google and Azure are all trying to build out their suite of serverless functionality so that basically they can get more business. This could be anything from Let's go with the transcode. So AWS has a transcode service for videos. Instead of spinning up an EC2, you just send it via an API to transcode. And the more services there are, the more complex and the more advanced features you'll be able to do by basically joining together the pre-made services from the cloud providers. So, yeah, that's everything. I think that's the last question. And up next is achieving autonomous management with Datadog and integration overview with Alex and Monica.